Hi everyone, welcome to AI Exact channel. This is Akash Gangwar and today we'll be studying AOD lecture 2. In the previous lecture we studied about tangents and normals, basically the first part of tangents and normals. Now we'll be looking at the second part, which is basically tangents and normals on a curve from an external point. So in the first lecture we studied about tangent and normal to a point on the curve. Now we'll be studying tangent and normal from point on the curve. So something of this sort, right? Now let us try to understand the process of finding the equations of normals and tangents in such a case. Let's say this is our curve and this is the external point P which has the coordinates alpha comma beta. Let's say we are dropping a normal over here and this point comes out to be, let's say, A comma B. We don't really know the point, but we are just assuming that it's A comma B, right? Now let's try to find out the slope of this line, this normal line. So for that, M tangent would be y dash and M normal would be minus 1 by y dash because mt dot mn would be minus 1. So the equation of this line would be, we know the point, we know the slope in terms of variables, that would be y minus b equals to minus 1 by y dash x minus a. This would be the equation in terms of variables. Now we know that this point alpha beta is going to satisfy in this equation, right? So we'll get one equation over here, one variable equation from here. And similarly, we know that a comma b point is going to satisfy in this curve equation. So we'll get another equation from here. So we'll get one equation from here and one equation from here, two equations, two variables, and we can find out a comma b, right? Now let's try to understand this method with the help of an example. So we have the curve given over here, y square minus 2x cube minus 4y plus 8. And we have the external point as 1 comma 2. So how does this look like? This is 1 comma 2 and we have to find out the tangents. So let's say we are dropping tangents from here. So this is the point, let's say a comma b over here. So let's try to find out the slopes of tangent. So for that, what we'll do, 2y dash minus 6x cube minus 4y dash equals to 0. This is 0 over here. So we'll be getting y dash minus 3x cube, sorry, minus 2y dash equals to 0. So from this, we'll be getting y dash equals to 3, not x cube, this is x square. 3x square divided by y minus 2. So this is our slope for the tangent. So this is our mt in terms of variables. Now we know that a comma b is lying on this tangent equation. So we'll find out the slope of this at this particular point by putting this value. So mt would be actually 3a square divided by b minus 2. So this is our slope at this point. Now let's try to write down the equation of the tangent. For that we'll be getting y minus b equals to 3a square b minus 2 multiplied by x minus a. We know that in this tangent 1 comma 2 is being satisfied. So we'll plug in the values. So 2 minus b would be 3a square divided by b minus 2 multiplied by 1 minus a. Now let's try to simplify it a bit. So we'll be getting b minus 2 whole square equals to minus 3a square 1 minus a. So this is the final equation. Now we also know that this a comma b point is going to satisfy in this curve as well because it's lying on that only. So we'll be getting b square minus 2a cube minus 4b plus 8 equals to 0. Now it might look like that it's very difficult to solve these two equations, but if we see it clearly, then we can see that b minus 2 whole square is forming over here. So b minus 2 whole square plus 4 minus 2a cube equals to 0. So basically b minus 2 whole square equals to 2a cube plus minus 4. Now, how do I get this idea that we'll be getting b minus 2 whole square? So first of all, in most of the question papers, even it's JEE or PGDBA or any other question, they won't be asking such lengthy equations where you have to, eliminate cube options or square options just by doing it manually. So there must be some kind of shortcut. So we could see that b minus 2 square is forming over here. So I could see b square, I could see 4b. That gave a trigger that okay, it might be possible that we can form b minus 2 whole square over here as well, and that actually formed. So this helps in eliminating this entire term. So now plugging this over here, what I'll be getting 2a cube minus 4 equals to minus 3a square plus 3a cube. So eventually we'll be getting a cube minus 3a square plus 4 equals to 0. So finally it comes down to solving this cubic equation, and there is no other method other than hit and trial to solve a cubic equation. Now I can clearly see that 1 is not satisfied over here, but 2 is actually satisfied over here. So a minus 2 is one root over here. Let's try to find out the other roots as well. So we have a cube over here. For that I'll write a square over here. So that gives me a cube. But I'll be getting minus 2a square with this. So I need minus 3a square. So I'll be adding minus a over here. But that will give me plus 2a over here. So I'll be doing minus 2 as well over here. And that gives me the entire breakdown of it. So finally this becomes a minus 2, a minus 1, sorry, a plus 1 and a minus 2, right? So this is our final equation that comes out to be a minus 2 whole square and a plus 1 equals to 0. So we are getting two roots from here. So basically we'll be getting 2 points from here. From that we can calculate b as well. So this is the basic process with the help of which you have to solve these types of questions. Now let's see one more example. Find the equation of all possible normals to the parabola x square equals to 4y drawn from the point 1, 2. Now again we have 1 point 1, 2 over here. This is one interesting question. I'll tell you why. And find the equation of all possible normals to the parabola x square equals to 4y. So we have a parabola like this, and we have to find out from a point 1, 2, and we have to find out normals on this parabola. Intuitively, if you look at it, then probably you will be able to see that one normal can be here, one normal can be here, and one probably can be here as well. So in case of parabola, what happens is we can draw three normals, maximum three normals from an internal point, and it looks very intuitive as well. So let's see how it goes mathematically. So we'll follow our method and we'll first find out the slope of the tangents and normals. So 2x equals to 4y dash. So basically y dash, which is nothing but m tangent, that would be x by 2. So basically m normal would be minus 2 by x. Now let's say the point is a comma b on the curve. So m normal would be minus 2 by a over here. Now I have to write down the equation of normal. That would be y minus b equals to minus 2 by a times x minus a, right? And this equation will satisfy this point 1, 2. So that would give me 2 minus b equals to minus 2 by a 1 minus a. So that eventually gives us 2a minus ab equals to minus 2 plus 2a. This cancels out. That gives us ab equals to 2. Secondly, this point a comma b would satisfy x square equals to 4y. So that would be a square equals to 4b. Now we have ab equals to 2 over here. Ab equals to 2. So basically what I'll be doing, I'll be doing a square by 4 equals to b. So I'll plug this value over here. That would give me a dot a square by 4 equals to 2. That would give me a cube equals to 8, which eventually gives a equals to 2. The other two roots would be non-real. So basically they would be imaginary. So the only possible value we get over here is a equals to 2. But now that becomes a little counterintuitive, and people might get into the loop and might not mark the correct answer in the examination when they see this. That I can clearly see this point is over here 1, 2, and I can assume that it's okay. It's forming at least two normals, but here mathematically we are just getting one normal. So how is that possible that with the help of intuition, with the help of diagrams, we are able to see that okay, we are probably getting two normals or three normals over here, but in mathematics we're just getting one normal over here. So let's try to solve that discrepancy. How is that happening? So basically it's a flaw of actually visualization and nothing wrong in mathematics. So let's see how it goes. And also this find the equation of all possible normals. That is also making confusion over here. It can make anyone confused during the examination. So let's see how it goes. So let's try to make a broader picture of a normal of a parabola. I'll prefer the horizontal parabola. So let's say I take a point over here. Let's say I take a point over here. Then it's clear I can draw a normal over here. I can draw probably a normal over here as well. And I can draw a normal over here as well. So these are the three possible normals I can draw. but let's try to take a point somewhere closer to the border. Then I can draw normal over here. I can draw normal over here, but I cannot draw any other normal over here. I can just draw two normals from here. Now let's try to plot a point from over here. Then I can see that I can just draw normal over here, but I cannot draw normal here, here. I cannot draw, because even if I try to do it forcibly, then also I will be not able to draw a normal from here. What does that show? We'll be getting a cubic equation over here, but our point is somewhere over here in this particular question, and that's why we are not able to draw other two normals and just single normal over here, right? So that is how it is. So it is maximum three normals and minimum one normal. So whenever you take a point, you can draw at least one normal, but it's not the case that you will be able to draw three normals in every single case. I hope that clarifies the visualization part as well. Now let us discuss some important points and terminologies. So the first one is equal inclined, second one is equal intercepts, third one is equal lengths from origin. So basically we are going to discuss the concept of angle between two curves. So that is why I'm discussing this as a prerequisite, because you'll be finding these kind of terms in the questions and you might be confused how to interpret these terms. So the first one is equally inclined. What do we mean by inclined? So basically, if we draw a line over here like this and draw a line over here like this, in that case, this is theta, this is theta, this is theta, and this is theta. So I would term this equation, this line, as equally inclined with the coordinate axis. Basically, this is theta, this is theta. Some might get confused that when we are saying equally inclined, then we are considering the mathematical angle which we calculate from the counter in the counterclockwise manner. But that is not the case over here. We are just calculating the inclinations with the help of respective coordinate axes. So this is theta and this is theta. And similarly over here, this is also theta, this is also theta. So basically this is 45, this is 45, this is 45, this is 45. So in both the cases, equal inclined concept is valid. So if we have seen written in a question that a particular line is equally inclined with respect to coordinate axis, that means that slope of line would be either plus or minus 1. In this case, this is plus 1 and this is minus 1. So slope can be assumed to be either plus 1 or minus 1, both ways. So we'll have two cases in such type of languages. In case of equal intercepts, now we know that when we're talking about the intercepts, we are actually talking about the distances along with the signs. So basically, intercept is nothing but this distance from the origin along with the sign. So if we are talking about the negative intercept, then we'll look at the left hand side. If we're talking about the positive intercept, then we'll be looking at the right hand side on the x-axis. Similarly, on the y-axis, upside means positive, downside means negative. So if we are talking about equal intercepts, that means both should be positive in the y direction as well, in the x direction as well, both should be positive. So that only means that m would be minus 1 only, not plus 1, because in case of plus 1, what will happen, this is negative and this is positive, so these two are not equal. So you can take the analogy with the help of vectors. In case of vectors, we take the signs as well, and not just the distance part. So you can take the analogy from there as well. Now if we talk about equal lengths from origin, then that takes the case of the other one. So basically in this case, this length is equals to this length equals to this length. So we have to take both the cases. So again, here just one case was there. Here two cases were there. Here as well two cases are there, because we are talking about equal lengths and not intercepts. So these lengths are equal. So slope can be plus 1 and minus 1 as well. Right. Now let's talk about the angle between two curves. So let's see how do we define angle between two curves. So let's say these are the two curves. If we try to define the angles by drawing tangents over here at this point, then it would be variable at every single point. I'm not making the diagram clear. Let's make it a little curvy. This is how it is. Yes. So let's say I'm trying to find out the angle between the two curves at some random points. So what will happen? I'll draw the tangent over here. I'll draw the tangent over here, and I'll see where these two are intersecting and find out the angle. But that would give different answer for different points, right? So we have to find out a way at which we can have a common answer in every single case. So that would give us the point of intersection. So we have to find out the tangent at point of intersection, and we have to find out the value of the angle between them over here. Now the main question comes out, how do we find out the value of theta from here? So for that, we'll go to the basic trigonometry. So basically, let's say you have line 1 over here, this is L1, this is having angle theta 1, and let's say this is L2 and this is having angle theta 2 from the x-axis in the counterclockwise manner. Now this angle would obviously be theta 2 minus theta 1, right? Now let's try to find out tan of theta 2 minus theta 1. So over here we'll be getting tan theta 2 minus tan theta 1 divided by 1 plus tan theta 2 dot tan theta 1. Now we know that if we talk about the slope, so basically tan theta 1 would nothing but slope of L1. So tan theta 2 would be M2 minus M1 divided by 1 plus M1 M2. Now, sometimes what happens is we don't really know how these lines are being placed, and we might consider theta 2 as the smaller one rather than the bigger one. In that case, we'll be getting negative answer over here because in the product, in the denominator, we have the product. So denominator is not changing, but numerator might change its sign if we mismatch over here, if we just replace it with one another. So basically, if we consider theta 2 as a smaller one and theta 1 as the bigger one, in that case, this answer might come in the negative one. So how do we interpret that? So basically, let's say these are the two lines over here. This is L1 and this is L2. Now, what we are focused over here, we have calculated this formula. So M2 is bigger. We have assumed that M2 is bigger than M1. In that case, that means we are finding out the acute angle. But in case we are getting the opposite one, we are finding out the obtuse angle. We are finding out the angles between both of them. But in the first case, we are finding out the acute angle. In the second case, we are finding out the obtuse angle. So there's nothing to be worried about. Both of them are considered to be angles between two lines. But as a standard practice, we try to take the mod whenever we have been asked a question that you have to find the angles between two curves or two lines, then we take the mod because we ultimately report the answer, which is the acute one, right? So that is why we take the mod over here. So you don't really need to worry if the angle is coming out to be positive or negative. You just have to take the mod, and you have to do the reverse as well. Suppose angle is being given, or basically this particular value is being given, and you are taking the mod, and then something is in there in variable. So you'll have to take two cases from here. So one is this case and one is the other case. So that's how you have to solve the questions. Now let's try to see this particular illustration. Find the angle between the curves y square equals to 4x and y equals to e raised power minus 6 by 2. So the given functions are y square equals to 4x, that is a parabola. The other one is the exponential function. Now there is no point of intersection given in the question, and also we know that by solving these two equations or functions, we cannot really find out the point of intersection with the methods which we know, right? So basically we cannot find out the point of intersection, and it's not given as well. So how do we solve these types of questions? So the first thought that should come to your mind when you see or when you encounter such type of situation, that the answer either must be 0 or must be 90 degree. Otherwise you cannot really find out the angle between these types of curves, right? So you'll have to assume that answer must be either 0 or 90 degree, and you'll have to think in that manner only. So let's try to solve it now. So let's say these two are intersecting at point A comma B, right? So let's try to find out the slope for this one. So we'll be getting 2y dot y dash equals to 4. So basically we'll be getting y dash equals to, sorry, 2 by y. So for this particular point, that would be 2 by b, right? This is y dash. Now for the second curve, we'll be getting y dash equals to e raised power minus 6 by 2 dot minus 1 by 2. And if we plug in the value over here, what we'll be getting? This is nothing but y only. So y dash equals to y dot minus 1 by into minus 1 by 2. And y over here is nothing but b. So y dash would be b into minus 1 by 2. So you can clearly see that if you try to multiply these two slopes, then you'll be getting minus 1 as the output. So when we are getting m1 m2 as minus 1, that means the angle between them is 90 degrees. So that was the trick over here. You might not have thought about it because you had no idea that it might be 90 degree or 0 degree. So once you train your mind that if we cannot find out the point of intersection and both the curves are not solvable, then you have to think in terms of 0 degree or 90 degree. Then probably you cannot take this kind of step over here, replacing e raised power minus 6 by 2 with the y, because this is y only, right? So you might not be able to take this decision from this to this if you don't think in this manner. So you have to first think in this manner and try to modify your equations in such a manner that you'll get the answer like that, right? Now let us talk about length of tangents, subtangents, normals and subnormals. And before that, we'll be defining what are these terms. So basically, let's say we have a curve over here and we are drawing a tangent and normal from this point. Let's say this point is A and it has coordinates h comma k. So we are dropping tangents and normals from this particular point. So the tangent is hitting x-axis at point C and the normal is hitting x-axis at point D. So this AC length is nothing but length of tangent, and this AD length, this is nothing but length of normal. And now the horizontal component of both these tangents and normals would be subtangent and subnormal. So basically the horizontal component of AC would be CB and horizontal component of AD would be BD. So CV is subtangent and BD is subnormal. So this is how we have defined the lengths of these four terms. Now let's try to solve these terms. So firstly, what we have done over here, we have defined theta over here. So if this is theta, then this is nothing but 90 minus theta, right? Because this is 90 degree, both tangents and normals are at 90 degrees. So this is theta, this is 90 minus theta. Now let's try to find out the value of AC. But before that, we know that AB equals to K, right? Because K is the coordinate of A point, this particular point. So K is nothing but AB length. Now let's apply basic trigonometry to find out the length of AC. So we know that AB by AC equals to sine theta, right? In this triangle ABC, we know that AB by AC is nothing but sine theta. So AC equals to AB cosec theta, right? We have got this relation. Now this theta would help us in getting tan theta equals to M. So for this particular line AC, M equals to tan theta, and we'll keep that in mind. I'll write it over here. Tan theta equals to M. Now we have to utilize this tan theta or M value to find out over here. Because we know this M value, we know the slope of tangent basically, we know the K coordinate, and we have to find out the length of AC in both of these terms. So basically we know this tan theta equals to M, and I'll try to find out the value of cosec theta in terms of tan theta. So if tan theta is M, then cot theta would be 1 by M. So basically 1 plus cot square theta would be cosec square theta, and that would be 1 plus 1 by M square. So if we take the under root, then we'll get the cosec theta value. So what we got over here, AC equals to AB is K times under root 1 plus 1 by M square. Similarly, you can find out the value of AD. For AD, you can just take the reciprocal case. We have 90 minus theta over here. So AD would be K times under root 1 plus M square, because that is 90 minus theta over here. We'll be getting sec theta over here. Sec theta would be nothing but 1 plus tan square theta under root. So we'll be getting 1 plus M square. So whatever you find over here, that is simply applicable over here as well in terms of sec theta. Similarly, you can find out the length of BC and BD in terms of tan theta and cot theta, and you will find out the values. So I'll just write down in the next page. We have got AC equals to K times under root 1 plus 1 by M square. We'll be getting BC equals to K into 1 by M. We'll be getting AD equals to K into under root 1 plus M square. And we'll be getting BD equals to K times M. So these are the four formulas you have to remember. Or else what you can do, you can just remember the derivation or understand the derivation, how to calculate these. If you're comfortable with that, you can derive these formulas in a matter of minutes, right? So either you can remember it or you can derive it. Both ways, it's fine in the PGDB examination. So today's lecture was till here only, and from the next lecture, we'll be starting with monotonicity, and after that, we'll be starting with local minima, global maxima, global maxima. So let's meet tomorrow. Thanks for watching.